Bismillahirrahmanirrahim and Assalamu alaikum. Rabbi shrah li sadri wa yassir li amri wahlul uqdatam min lisani yafqahu qawli. Dear students, our today's lesson is about the properties of enzymes, and this topic is related to your chapter number 3, which is about the enzymes. In this chapter, we will learn that what are the enzymes, what are their chemical nature, and what is the purpose of enzymes actually. At the end of the chapter, we will also learn some important aspects of enzymes. So today we will focus on the properties of enzymes. So the enzymes have all the properties which globular protein have. This line means that the enzymes are chemically protein in nature, and the globular protein means they are large size and complex type of proteins. So we will discuss their different properties in terms of catalytic nature, colloidal nature, their heat sensitivity, pH sensitivity, and the reversibility of the reaction. So we will discuss all these properties of the enzymes one by one. First of all, we will see that what is the catalytic nature of the enzymes. As according to the definition, that enzymes are biological catalysts which speed up the chemical reaction within the living body without getting consumed and without being altered. And we will see the meaning of this definition one by one in the terms of the properties of enzymes. So first property of the enzyme is their catalytic nature, that all enzymes are catalytic in nature, and very small amount of enzymes catalyzes a large quantity of substrate. What is the substrate? These are the reactants which are acted upon by the enzymes and are converted by the action of the enzymes into their products. So this is because the enzymes only accelerate the chemical reaction and do not lose or gain at the end of the reaction. That means they are, without getting consumed, can catalyze the chemical reaction within the living body. So they do not undergo any quantitative or qualitative change. Quantitative change means their amount is not altered at the end of the reaction. That means that without being consumed, they can catalyze the reaction. And the qualitative change means there is no change in their protein nature or the structure. So without being altered, they are getting back at the end of the reaction. Now the next property is related to their colloidal nature. That means as enzymes are high molecular weight compound and are large in size, also show a very slow rate of diffusion. That's the reason they form the colloidal solution in water. So these are the colloidal in nature. That means they are not completely dissolved in water due to their large sizes. The next property is called the heat sensitivity, as the enzymes are specific to heat sensitivity. These are inactivated by the low temperature. So the temperature is very important factor which can change or which can affect the enzyme reaction or enzyme rate of reaction actually. So that means when the temperature is increasing, the initial there is the initial you can say increase in the rate of the enzymatic reaction, but to a certain limit. When the temperature is crossing this certain rate limit, so the enzymes will show the decline in the rate of reaction, and after increasing a very high temperature, which is about 60 degrees Celsius, they become denatured. So normally above 60 degrees Celsius or the centigrade temperature, enzymes get denatured and lost their catalytic property completely. Denaturation means now the enzymes had stopped their catalytic activity, and become denatured means they have their structure is collapsed actually. So they will no more can catalyze the reaction. But at low temperature, which actually at 0 degrees Celsius, when the rate of the diffusion becomes slow, they become inactive. But when the temperature is increased, they can restore their catalytic activity. But after the denaturation, they will not able to carry out their catalytic activity. So at initial stage, a low increase in the temperature enhance the rate of the reaction, and at a certain limit of the temperature, which is called the optimum temperature, enzyme will show its maximum rate of reaction. That is the reason this temperature will be known as the optimum temperature. So every enzyme have its optimum temperature, and they are most active from 5 to 40 degrees centigrade temperature. In terms of the next property of the enzymes, we will discuss their pH sensitivity. Enzymes are also pH sensitive, and they are the most active at the pH of 6.5. Some enzymes are active in low pH. Examples are pepsin and rennin. So the pepsin can work even at 1 pH, while some enzymes are also active on high pH. Example is the trypsin, amylase, and lipase. Trypsin even can work at a pH of 8. So next we will discuss another property of the enzyme, which is called the reversibility of the reaction. Enzymes can also accelerate the rate of reaction in any direction. It is taking place that it is the both direction provided suitable source of energy are available. For example, the enzyme lipase is required for the synthesis of fat from glycerol and fatty acids. The same enzyme is again required for hydrolysis of fat, and hydrolysis means that it's the conversion of fat into the glycerol and fatty acids. So both the condensation and the hydrolysis of fat can occur with the same enzyme, which is called the lipase. So that is the reversibility of the reaction. So students, these all are the properties of the enzymes. Thank you and Allah Hafiz.